Do not copy on the questions. I have to do some notes first to help you understand what's going on in the lesson. So put your pencils down, please. So what we're basically doing, it was going to be a weekend homework, but now we're formally covering it in class. I was guiding you on the weekend homework, but we're formally covering it in class. In simple language, what we're doing is this. Please write this down. We're basically approximating any function using a polynomial. And that's like magic. Say f of x. In other words, I can write sine x as a polynomial, cosine x as a polynomial. You'll be amused and amazed to learn your calculator for sine x, when calculating sine x, actually uses this algorithm. It uses a polynomial to approximate sine x. It does not have a sine x function. There is no formula for sine x. It's not going to do opposite over hypotenuse or y over r. It actually uses a polynomial approximation in its algorithm. Those who are in computer science will know what I'm talking about. Alright? So if you'll put your pencils down, so I'm just showing you what's going on. In the first semester, we did a tangent line approximation. So that's a first degree polynomial. First degree polynomial just means linear. Okay? So f of x equals ex. We're approximating ex at 0. Okay? That's our goal. So we just fit a line. In the first semester, we said, oh yeah, if you're not far away, can you see that's a fairly good approximation? But can you see, now that is a second degree polynomial approximation. Do you observe this gray curve? This, is that not a better approximation? You can for a greater range. Okay, the line is valuable only till here. But the second degree is valuable even till here. Can you see? It's a better approximation. So higher the degree of the polynomial, the better the approximation. This is the cosine x function. They are using a 6th degree polynomial to approximate cosine x at 0. Do you observe this, even though we are approximating at 0, the approximation is so good till here, to here. You can kind of use it for any of these values. But I'm just showing you the higher the degree, the better the approximation is. Here's more examples. So that's the log graph. So we're first doing a tangent line approximation, what we did in the first semester. If I zoom in, they're like virtually the same. But that is a second degree approximation. We're fitting a parabola. But can you see from here to here, it's kind of good. And this is basically the question says, as n increases, as the degree of the polynomial increases, the graph of Pn becomes a better and better approximation of graph of ln x near x equals 1. These two examples, we were approximating close to 0. And the good news is 9 times out of 10 we'll be approximating about 0, okay? Close to the y-axis. But sometimes we may approximate some other value at x equals 1 here. This is the third degree polynomial. For the same ln x graph as the third degree polynomial. This is even better. From here to here, you're pretty much good. And that is a fourth degree polynomial. That's even getting better and better. So that's the sine x curve. But we're approximating close to pi over 6. It is like 30 degrees, pi over 6. And they fit a third degree polynomial. That's pretty good, not bad at all. From here to here, kind of good estimate. Okay. Anyway, so that's our lesson. How are we approximating? Like, what polynomial can we come up with? That's like magic. I want you to think about it. No matter what function you give me, I can approximate easily a polynomial. So during lunch, I was showing Mr. Park. Mr. Arnold, what's this? So this is the sine x curve. Now today's lesson, we will learn this. So assume this is the sine x curve. Okay, I'm going to zoom in. Okay, the polynomial, we will learn this later. If I just do x, okay, that's that guy. Not good enough. What's this? X minus x cubed over 3 factorial. Whoa, a better approximation. Okay, now I'm going to do an even better approximation. This is a pattern. And we'll do plus x to the power of 5 over 5 factorial. Oh, an even better approximation. Keep in mind we're trying to approximate the red guy. Keep in mind, okay? Now here's an even better approximation. I'll just increase the degree. Make a guess. What should your next term be? Make a guess. Plus Minus, right? It's flipping. Minus x to the power of 7 over. Okay, that's today's lesson. Whoa, even better. Can you see it's better to the red guy? Have a look. Let me suppress all the others. Wow, that's pretty good.
The red one.
And the more terms you add, and that's what I'm trying to get across. The higher the degree of the polynomial, the better the approximation. It's amazing. Now, I want you to actually think and marvel at what's going on. Mathematicians have figured out a polynomial approximation to any function. Give me any function, I can approximate using a polynomial. Now I'm letting you know your calculator uses that algorithm. So when you're finding sine of 90 degrees, sine of pi over 2, it is actually plugging in pi over 2 there. It's not easy to plug in. Those of you in computer science, it's just evaluating a function at pi over 2. It's very easy to do. Okay? But we're going to discover how does that formula come into play. Okay? So now this is the key idea. Here's my pen gone. Is a black one? Oh, it's still there. Okay. Now the general idea is this. The general polynomial function is just this. Please write down. This is the general nth degree polynomial. About x equals c. So don't get alarmed by x equals c. It just means x equals 1. X can be 2. Can you see you're approximating here x equals pi over 6. Here it was x equals 1. Okay? This is x equals 1. So whatever your approximation point is. So this is the general idea. So f of x equals. Okay, a is 0. I do not know what that constant is. We're trying to estimate that, figure out what that constant is. For those of you who say, I don't know what you're talking about, look at the board. Can you see? My constant is 0. Can you see there's no constant? Can you see every term has an x term? So there is no constant term. But I'm saying, I'll start with a0. My second term is x minus c. Okay. My third term is a2, x minus c squared. If I need a parabola, that will be my general term. If I need a cubic function, I'll do a3, x minus c cubed. Okay. That's the general form for the cubic. Plus, dot, dot, dot. If I want an nth degree, so you say 10th degree. So it's like an, x minus c to the power of n. Okay. So my goal, in case you're saying, what are you talking about? My goal is to find this guy, this guy, this guy, this guy, and I'll have the polynomial. So look at the board so you can make connections. So can you see the linear guy has a degree of 1. The cubic guy has a coefficient of 1 over 3 factorial. That's what we're finding. We're finding those guys. I want to see if learning is happening. Which is the quadratic guy? The quadratic guy has a coefficient of. The quadratic guy has a coefficient of. Quadratic means degree 2. The quadratic guy has a coefficient of 0. There is no quadratic. There is no quadratic. Remember? So this guy, all I'm trying to say is that A2 was 0. Is that clear? The cubic guy has a coefficient of wrong. Negative 1 over 3 factorial. The quartic guy, quartic in math means 4th degree. The quartic guy has a coefficient of 0. The 5th degree power has a coefficient of 1. See, our goal is to find those guys. I'm going to show you how. Is that clear? So the concept is this. Now here's the big reveal. Mr. Park did not get that. During lunch we were talking about it. He said, oh, now it makes total sense. I'm going to use f of x to approximate, say, sine x. I'm going to say something profound, think about it and say, oh yeah, that's true. If two functions are exactly the same, I'm going to speak slowly so you can grasp this idea. If two functions are exactly the same, should their derivatives be exactly the same? Because I'm saying they're the same functions. Is that a fair point? Should their second derivatives be exactly the same? Because I'm telling you they're the same functions. Should their third derivatives be exactly the same? And so on. And we'll use that idea. Alright? So I'm going to take the derivative of this guy. So play along. Oh, first, I can find a0 very easily. I can just plug in f of c. Let me just find f of c. So should I just replace every x value with c? So look down. What happens to the second, third, fourth, till infinity turns? Does it become 0? Which is the only guy that does not collapse? So if I find f of c, will I get a0 immediately? So it helped me find a of 0. So make a note, a of 0 is f of c. Put a box around that. Observe the goal. The goal is to find out these coefficients. Okay, next, I'm going to take the first derivative. Okay, I'm going to take the first derivative of this function. So in other words, I'm going to go f dash of x. What's the derivative of a0? Hint, a0, a1, a2 are all constants. So what's the derivative of the first term?
0.
Okay, that's a line. X is the variable, c and a are constants. What's the derivative of a1, x minus c?
A1.
Thank you, a1. Okay, what's the derivative of, hint, we're using power rule, chain rule. What's the derivative of a2, x minus c squared? 2a2, x minus c. Plus, what's the derivative of a3, x minus c cubed? 3a3, x minus c squared. Plus, I'm just going to write the next term even though it's not there. Make a guess. What's the next term going to be? 4a4, x minus c to the power of 3. Very good. Plus, dot, dot, dot. an times n, or nan, yes, last term, power rule. X minus c to the power of n minus 1, plus dot, dot, dot. Now remember, my goal is to find a1. If you paid attention to patterns, what should I just do? Sorry? Plug in C. Will all of these collapse now? So I'm going to do f dash of C. So left hand side is f dash of C. Again, all of these, do this gently. Don't actually scratch it out. Can you see all of these will collapse? Do I just get A1? And A1 is f dash of C. Oh, I found the second constant. Okay. Make a guess. What do you think I should do next step? Take the second derivative. Thank you. F double dash of x. What's the derivative of the first term? What's the derivative of the second term? 2a2. Plus, what's the derivative of the third term? Stop! I'm not going to write 6. You can totally write 6. But I'm going to have you make a discovery. I'm going to write that as 3 times 2. Just play along. 3 times 2, a3, x minus c. You'll see in a moment why. You'll say, oh my god, that was smart. Plus, what's the next term going to be? 4 times 3. Very good. a4, x minus c squared. Plus dot dot dot. an, n minus 1, x minus c to the power of n minus 2. What simple operation will help me find a2? Plug in c. F double dash of c. Will all of these guys collapse? Which is the only guy left over? 2a2. But guys, I need a2. So what should I do to both sides? Divide by 2. Is that f double dash of c over 2? Put that in a box. Because that's my goal. My goal is to find out these coefficients. Mr. Nguyen, are you able to see the board? Do you want to come and sit here?
Yeah, I'm fine.
You're fine? Okay. Okay, find a3 yourselves. Go on, look down, find a3 yourselves. Find the derivative and plug in c. You'll start seeing a pattern. So f double dash of x equals 3 times 2, a3, plus 4 times 3 times 2, a4, x minus c, plus dot dot dot, an, n minus 1, n minus 2, x minus c to the power of n minus 3. Therefore, f triple dash of c equals 3 times 2, a3. Therefore, a3 equals f triple dash of c over... Nah, don't write 6. What? How can I write 3 times 2 as?
Oh, 3
3 factorial! Because, remember, look at the board. I can write 2 as 2 factorial, isn't 2 times 2 times 1? We want a pattern here. F double dash of c over 2 factorial. Go back to f dash of c. So a1 is actually f dash of c over 1 factorial. We have a pattern. There's 1 factorial, there's 1. Eunice. Make a guess. We're almost done. Make a guess. What do you think A4 is? Now we don't have to do any math. Look here. Make a guess. Intelligence is observing patterns. What do you think the numerator is? F4 of C over 4 factorial. Therefore, an, the nth coefficient, will be Fn of C. This is how we write it. Fn of C over n factorial. And that was my goal. My goal was to find out all those coefficients. So we can go back and write the entire polynomial. So big discovery. So now I'm using jargon. So what we just found is called the Taylor polynomial. Just play along. It's just after the mathematician. Please write this down. So the Taylor polynomial for f of x about x equals c is f of x. Remember we wrote a is 0? Look at your notes. It's one of the boxes. What was a of 0? F of c plus, it was a1. What was the a1? Look at the box. Was that f dash of c over 1 factorial x minus c? Look at your notes. We needed a2. Sorry, a1. No, a2. What is a2? Look at your box. F double dash of c over 2 factorial. Okay, now don't look at your notes. What should your third term be? Make a guess. Triple dash of c over... Oh my god, Hansen is not here. It's probably in Mexico. Kidding. Plus dot 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 fn of c over n factorial x minus c to the power of n. And that is my nth degree polynomial. Magic. Okay? So if I wanted, look at the board please. So for this problem, for those of you wondering, for this problem, can you see, I'm speaking so on the board, it says about x equals 1. So c is 1, is that clear? They're saying about x equals 1. They're telling you what c should be. The problem will give you that. Alright? But most of the time, we just need to be centered at, most of the time we are centering at 0. So isn't c 0? And that, you're learning a new word, it's called a Maclaurin polynomial. So please write this down. Maclaurin polynomial is basically a Taylor about x equals 0. So I'm just going to plug in c to be 0. Okay, I'm going to plug in c to be 0. So it becomes f of x equals, what does the first term become? F of 0 plus, what does the second term become? Look down. F dash of 0 over, and then x minus c becomes? Thank you. X. What does the third term become? 0 over times. Very good. Next term becomes over x plus dot dot dot, and the n term becomes n of 0 over x to the power of plus dot dot dot. And that is the Maclaurin formula. I want you to relax. Moving forwards, Mr. Arnold at the back, he's just attending to make sure he gets the idea. Now it's all formula driven. So we spent all this time discovering what that formula is. So remember I used Desmos to get this? Look at the board. Remember I got that? Oh, if you use this formula for the sin x function, this formula will magically appear. Oh, do you see the factorials appear? Because of that formula. So relax. So before I move on, I want you to spend 30 seconds especially memorizing these two formulas. Sit down. I'm giving you class time to memorize them. Because I'm going to race through this. I'm not letting you know. I'm letting you know so you won't be surprised. Mr. Arnold will tell you the class just moved on in a very rapid pace. Because we're just going to use the formulas. Yes, Ms. Eunice.
When we're writing
Yeah. Yeah. That was the end of the question, see? Here. A1. No. The actual question. A0, A1, A2, A3, x minus c squared. The original expression for the polynomial had those powers, right? We just plugged in A0, A1, A2 into that original first step. Again, master the two formulas are very similar, but observe patterns. Intelligence is observing patterns, like I understand the general pattern. I invested 10 minutes as discovering where's that formula coming from. But we'll never look at them again. We're just going to use the formula for every step. Okay, can you copy down number 1, please? I'm going to show you. So we're going to fit a third degree polynomial for that guy. So we have a crazy looking function. I'm going to fit a cubic function to approximate that about x equals 0. Okay, I'm helping you understand this, so your homework will go faster. For those of you not aware, for those of you who have checked your email, have you observed the homework has been sent? Okay, it's time for about 50 to 55 minutes. If you do your homework earlier in the evening, guys, you're learning something new. I'm letting you know it's an absurdly easy lesson. Do not do your homework at 10, 11 at night saying, man, I've forgotten everything. It was an easy lesson to begin with. I thought I understood everything. Now I'm grasping. Okay. Oh, by the way, give me 2 reasons why this is a Maclaurin. Read the question. Assume the question did not say this. How do I know it is a Maclaurin polynomial, not a Taylor polynomial? They did not give us about x equal. Can you see that? If it was a Taylor, they would say about x equals something. Can you see? They did not give that. So it's understood about x equals 0. Is that clear? So immediately I'm going to use the Maclaurin formula. Oh, another thing to help you, write this down. Some of you will benefit. Kids every year say, man, Rama, that helped a lot. Here's how you tell them apart. M comes before T in the alphabet. That's Maclaurin, that's Taylor. The spelling is Maclaurin. Right? M comes before T in the alphabet. X equals 0 comes before x equals C. Okay, 0 is initial, C comes later. Okay, how to tell them apart. So if they do not mention x equals 0, it's understood to be x equals 0. So it's always Maclaurin. But if they give you an x value, then it means Taylor. Is that clear? Again, Taylor has a value. Maclaurin comes before, so that's 0. All right. So first step for all these questions is write the formula. It says third degree polynomial. So let's write down. I hope you copied the question down. I'm going to race through this. Okay, so who already has memorized the formula for Maclaurin series? F of 0, f dash of 0 over x plus over x square. Read the question. Read the question. How do I know when to stop? Third degree. Pay attention to the question. 0 over 3 factorial x cubed. Should I stop? Yes. Now, observe the board, please. It's my goal basically to find this guy, this guy, this guy, this guy, and we get to go. Can I just read the question? Just by staring at it. What's f of 0? 0. We're done. What else do we need to find? I need to find f dash of 0. So let me speak slowly. What should I find first, after which we can plug in the 0? F dash of x. Should we use product rule? Look down, please. I'm going to race through this. Keep the first guy fixed times negative e negative x plus e negative x times 1. I'm going to plug in 0 immediately. Does the first term collapse? The second term is 1, correct? So f dash of 0 is 1. My second term is there. Rewriting is your friend. So negative x, e negative x plus e negative x. I'm just rewriting it so I can take second derivative. So I'm going to find f double dash of x. Look down, please. Again, product rule. Keep the first guy fixed times negative e negative x plus keep the second guy fixed times negative 1 plus e negative x. Oh, Arnold, we made an error.
I know, I was going to ask you.
Oh, we made an error in the other class. It is negative e negative x. We got plus e negative x.
You said it canceled, but it never did.
Yeah, it doesn't cancel. Okay, I thought, last year, I knew, because I have a good memory, I knew it did not cancel. I was like, man, how did these terms cancel? Okay, I'm going to plug in 0. Will that first term collapse? Is the second term negative 1? Is the third term also negative 1? So is f double dash of 0 negative 2? Okay, rewriting is your friend. So f double dash of x is positive x e negative x. Is that minus 2e negative x? I hope you understand your algebra. Those are exactly the same expressions. Okay, now I'm going to type f triple dash of x. The last one. Wait a second, is this what the original problem was? Can I just copy that down? It was negative x e negative x plus e negative x plus 2e negative x. Yes? Will the first term collapse? So f triple dash of 0 is 3? Yes, 3. Am I basically good to go? For those of you not following, look at me. I just need to plug it back in there. So my goal is to find these coefficients. I'm plugging back in there. Arnold, you should have told me, man. I don't yell if you point out errors. I sometimes scold Wadinius because he and, Mashari, he and kind of chatting.
Yeah.
I yell at that, like, man, get back to the class. I don't yell at students. Okay, so final answer, write down f of x equals. Was f of 0 1 or negative 1? Oh, 0, okay, that collapses. F dash of 0 is 1, correct? So that's 1x. What is f double dash again? Was it negative 2? Okay, negative 2. Now guys, look at me please. The AP expects you to simplify the factorials. What's 2 times 1? Over 2, x squared. What was f triple dash again? Was it 3 or negative 3?
3.
Careful. What's 3 factorial? 6, very good. X cubed. Rewriting is your friend. So your final answer, x minus x squared plus 1/2 x cubed. That is your final answer. Now, put your pencils down so you understand what the whole result was. We are saying that cubic is an astonishing approximation of that guy, close to 0. Is that clear? That's what we're saying. That cubic polynomial is a really good approximation of that guy. That's what we're saying. Any questions about the process? It's stupid. It's formula driven. Write down the formula. Another thing, please. You need to. The AP requires you to simplify the factorials. You cannot leave it like that. You cannot leave it like that. So this is your final answer. It has 2 points. 1 point, another point. Okay, let's do another problem. Copy down 2, please. Now I'm going to race through this. I'm warning you, I'm going to race through this. Even if they did not give me clearly Taylor polynomial, how do I know it's a Taylor polynomial? It says about x equals pi. Is that clear? So make a note to yourselves if you need to. Basically, they're saying C is pi because x equals C. They're telling you the C value is pi. So what you plug in into the Taylor formula is pi. Is that clear? Okay, I'm writing the Taylor formula. Feel free to peek if you need to, but try to do it from memory. What's the first term in the Taylor polynomial? But C is pi. So what am I writing? Don't waste your time writing f of C. That's the general formula. Plus, what's the second term? F dash of pi over x minus, very good, plus third term. Now look at patterns. Third term over x minus pi, very good. How do I know when to stop? They say fourth degree. Pay attention to the question. Plus f triple dash of pi over 3 factorial x minus pi cube plus f4 pi over 4 factorial x minus pi to the power of 4. So what are the 5 things I need to find? F of pi, f dash of pi, and so on. So guys, relax. Arnold will tell you this was very rapid. Can we just plug in pi? What's cos of 2 pi? Times 3? 3, so that's 3. F of pi is 3. Should we find f dash? Okay, now look down. Will it be negative 6 sine 2x? Yes? So what will f dash of pi be? Hint, sine of pi, or sine of 2 pi? 0, so that's 0. It collapses. Let's do f double dash of x. Negative 12 cos 2x. Therefore, f double dash of pi is negative 12. Very good. Cos 2 pi is 1. Let's find the third derivative. F triple dash of x is positive 24. Very good. Cos 2x, sine 2x. Therefore, f triple dash of 0 is 0. Guys, this is not optional. Don't do this in your head. The AP requires this. Sorry, go on. Oh, so you're right. Of pi. Thank you. And then finally, the fourth guy is this positive 48 cos 2x. Therefore, f4 of pi is positive 48. Now look down, please. Which guys were 0? Was the odd one 0 or even one 0? The odd. So look at the board. I'm making your job easier. Go to the odd guys and just collapse them, so you're not wasting your time. So I'm going to just plug into the leftover. Now look down. I'm erasing, so you need to look down and help me. So f of x equals, what was f of pi again? 3. What was f double dash again? Look down. Negative 12 over 2. Very good. X minus pi squared. And then was f fourth 48? What's 4 factorial? 4 times 3 times 2 times 1. 24. X minus pi to the power of 4. Absolute final answer, 3 minus 6. X minus pi squared plus 2. X minus pi to the power of 4. That wasn't bad at all, right? And that's your answer. We're saying this polynomial is a really good approximation of that function about pi. That's what we're saying. Okay. Write down number 3. Copy down number 3. Again, copy down number 3, please. Taylor or Maclaurin? It says x equals 9, even if they did not formally give it to you. So keep in mind, in your mind, C is 9. They're giving us x equals C, and they're giving you x equals 9. So let's start with the formula. F of x equals, what's your first term? F of 9 plus f dash of 9 over 1 factorial x minus 9. Smart kids, read the question again. How do I know when to stop? So stop. I'm blowing your minds. Do you observe there's a, look at me. Do you understand there's a difference between 3 terms and third degree? Is it not tempting to write the next term also? But they just say 3 terms. Now what's this? The AP is super strict. This comes in an FRQ. If they say 3 terms and you know third degree, they take off points. Even though the first 3 terms are perfectly right and you're fourth, how many of you understand what I'm trying to tell you? Do you not write an extra term? And they're saying you can't follow instructions. We only are approximating the second degree polynomial, which is 3 terms. Why are you writing that third degree polynomial? We don't want that. So pay close attention. So plus f double dash of 9 over 2 factorial x minus 9 squared. Everybody okay there? If you want to write good notes or your last name rhymes with win, write down third degree versus 3 terms. These are 2 different ideas. These are not the same things. So in your homework, in one of the questions I said, psst, careful. But in spite of that, Ms. Marzu does not pay attention at times. I just say, Marzu, did you, when she's on the phone with me, I say, Marzu, did you even read the psst? I was helping you there. You did not read the instructions. Okay, mentally, what's f of 9? 2, so sidebar, f of 9 is 2. Okay, f dash. Who remembers from first semester derivative of radical monkey? 1 over 2 radical monkey. We don't have to use chain rule because it's times 1, correct? Therefore, f dash of 9 is 1 over 4. Okay, now careful. Who remembers how we find that derivative? What do I need to do first before I can find its derivative? Rewrite it, thank you. So see if this comes back. X minus 5 to the power of negative 1 half. 1 half outside. Now I'm ready to do f double dash of x. So the outside coefficient really becomes negative 1/4. X minus 5 to the power of. Okay, now rewriting is your friend. I'm going to pull it down. X minus 5 to the power of 3 halves in the denominator. Okay, now do this with me. 9 minus 5. Square root. Cube it. Times 4. So it's negative 1 over 32. Okay, I'm ready to plug it in. So f of 9 was 2. F dash of 9 was 1/4. Guys, look at the board. I'm helping you. So it'll be faster on your homework. You're going to smarter at times 1 factorial. Okay, I'm not forgetting that. And then x minus 9 plus f double dash of 9 was, negative 1 over 32 dot 2 factorial x minus 9 squared. Okay, that 2 factorial can't vanish. Last step, 2 plus 1/4 x minus 9 minus 1 over 64 x minus 9 squared. That's the quadratic. Look down, look down, look down. I'm just simplifying. Look down. Okay, before I move on, this is stupidly simple. It's extremely formula driven, guys. I showed you how the formula comes into existence. You're writing the Taylor-Maclaurin formula, plugging it in, find what you need to. Okay, now there are some functions. Look at me. I sent an email yesterday saying, okay, AP5 kids memorizes automatically. There are some functions that occur very frequently in engineering. So we've done all of this for those functions and we have a series. So copy this down. You'll have to go home and memorize them. But I'll give you class time to memorize them. So copy these down. So these functions occur so frequently in calculus. We've already done the formula for these, the left-hand side. And we have the right-hand side. I need you to make good notes and memorize them. Girls, you may want to make flashcards. Because girls love flashcards. Okay, I'm giving you time to copy that down while I take a roll. Okay, I'm going to scroll down so you can copy down the other formulas. Okay, take down even EX at the bottom. Okay, and I'll show you how to memorize them. Oh, there's one more there. Huh? Okay, hurry up, please. Okay, has everyone written those down? Okay, if you'll put your pencils down, I love Eunice, she's already memorizing it. Let me give you some tricks to memorize. Look at the board, please. Okay, put your pencils down so I can give you some tricks. Only look at the board. This is not the time, Marquez, to look elsewhere. So these two go together. So let me show you how to memorize this. If you have a 1 over 1 minus x, all of those are pluses. Observe, all of those are pluses. But if you have a plus, it's an alternating series. It's 1 minus x plus x squared minus x cubed and so on. So observe that pattern. So repeat. If you have a minus sign in the expression 1 over 1 minus x, all of them are pluses. It's easy. 1 plus x squared plus x cubed. But if you have a plus sign, they flip-flop. So observe that pattern. Next, I want to show you sin x and cos x. Now, for those of you who have forgotten, write this down if you want to. The sin x function, I'm sketching the sin x curve. This is the sin x curve, is an odd function. Oh, if you understand that idea, sine only has odd powers. Have a look. And they are alternating series. X minus x cubed over 3 factorial plus x5 over 5 factorial minus x, and they flip-flop. Okay? Another thing, I'm speaking, so look at the board. Do you observe the power and the factorial are the same numbers? Observe that trick. Another thing, are these all not odd numbers? Now, on day 109, just before we left, isn't 2n always an even number? If you add a 1, it becomes odd. So that's how you get the n term. Cosine function, write this down if you want to know why. The cosine function is an even function. So it has only even powers. It's easy to remember. Now some of you will say, no Rama, that's 1. But isn't 1 actually x to the power of 0? So it does have an even power. So it has only even powers, so hence x2n over 2n factorial. It also flip-flops. 1 minus x squared over 2 factorial plus x4 over 4 factorial and so on. Okay. The tan x, write this down if you want to, tan x is also an odd function. Here's the tan x curve. The tan x is also an odd function. So it behaves like sine. Now look at the similarity between tan inverse, of course it's inverse, the same idea though. Look at sine inverse, look at this. Do you observe these guys have factorials in them? Observe how easy it is to memorize. Isn't it exactly the sign without the factorial? Have a look. It is exactly the sign. If you memorize that, you know the tan inverse because you don't put the factorial. Is that clear? Now, EX is a series, the most important series of them all. It's the easiest one to remember. Is that 1 plus x squared over 2 factorial x cubed? So there's nothing skipped. All of them with factorialism, all plus signs. It is not an alternating series. And this one has its own pattern. It's x minus x squared over 2 plus x cubed over 3. It's alternating without a factorial. But observe the pattern. But I need you to go home. But I'll give you about 1 minute to look over them to see if you get some pattern quickly. So you can race to some of the problems. Okay, look down, look down, look down. Guys, bad news. The good news is on your homework, I'm giving you formula practice. If, when you have to kind of vomit out the formula without peeking, you keep looking at your notes, you're not helping yourself. Again, Ms. Yunus, I know for a fact, Ms. Jung, Ms. Yunus, Ms. Marzouk will go home and study and do the homework without peeking. But if you say, man, I'm not going to remember it, I'm just going to constantly look at my notes and then write down, you're not helping yourself. You're not doing yourself any favor. You don't have options. Let me show you a calculus textbook. Oh, this one is taken. But I showed the other class, Arnold Witness. I showed a box. The calculus book has a box with all these formulas in them. You have to memorize them. Okay, now copy down number 4, please. Okay, I'm going to race to this, so stay with me, please. It says write the first 4 terms and the nth term of the power series for that. Okay, looking at your formulas, which series do we know the expansion for? EX. So first step, write down the EX series. Very quickly. Guys, on the AP exam, this is a 2.5 minute problem, comes in multiple choice. 1 plus x over 1 factorial, x squared over 2 factorial, x cubed over 3 factorial, plus dot 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 xn over n factorial. It says first 3 terms and the nth term. They also call it general term. Next, do we not need e to the power of negative x squared over 2? If you understood the weekend homework, I should replace every x with negative x squared over 2. Mr. Arnold, in your class we went too fast, so I'm going to slow down and actually show that step. So it's 1 plus negative x squared over 2 over 1 factorial. It's smart to do that, so you won't make, otherwise you have to do a lot of mental math, see? Plus negative x squared over 2 over 2 factorial. Plus negative x squared over 2 over 3 factorial. Plus dot 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 negative x squared over 2 to the power of n over n factorial. I'm going to simplify this. Look down, please. Look down. Is your second term just negative x squared over 2? Yes? Okay, there's a square here. What's negative square going to be? Positive. What's x square going to be? X to the power of 4. What's 2 square going to be? Divided by 2? No, 8. Because it's 1/4 divided by 2. So divided by 8. Okay. What's negative cube going to be? You're taking way too long. Negative x to the power of 6. What's 2 cube? What's 1/8 divided by, this is 6. What's 1/8 divided by 6? 48 plus dot dot dot. Now observe this. Observe how we write the last guy. Is that negative 1 to the power of n? Okay. Is that x to the power of 2n? Over 2 to the power of n dot n factorial. Observe how that was written. Again, negative to the power of n, x to the power of 2n, 2 to the power of n over n factorial. Are we there yet? Read the question. Read the question. Are we there yet? What do we need to do last step? Hint, that's e negative x squared over 2. What do I need to do last step? Multiply by x. So I'm going to do x times. So this is e to the power of negative x squared over 2. I'm going to multiply every term by x. Is that clear? So what is the first term going to be? Minus, over, plus, over, minus, x, over, look down, plus dot dot dot, negative 1 to the power of n, over 2 to the power of n, n factorial. Guys, x to the power of 2 and I'm going to multiply by x. What does the power become? Very good, 2n plus 1. We are adding powers, remember? That's how easy that was. Okay, start with the series you know, replace, use function notation, composite function from IM3, replace every x with negative x squared over 2. Show the work, simplify, this is all basic algebra. Let's move on. Copy down number 5, please. Again, copy down 5. Quick. I have to do one more problem after this. So copy down 5 quickly. So start with series you know, and then we're just making small modifications. Okay, they say g dash of x equals f of x. And they say write g of x. Oh, first, write g of x as a series. Write the power series for g of x. What operation should I do to get g of x? They're saying g dash is f. Louder? I can't hear you. Integrate, thank you. Should I integrate both sides? And it will give you g of x then. I'm just going to integrate both sides. So then g of x will become f of x. Integral of f of x. Everybody okay there? Did everybody understand what's going on? Now look, have they given us f of x? But they want a series for f of x. Now look at your series if you need to. Which series is that guy closest to? 1 over 1 minus x. So start with a 1 over 1 minus x series. You should be very, very quick. Hint, that's a negative, so the series is only positive, guys. If you remember my trick. So 1 plus x squared plus x cubed plus dot 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 x to the power of n. Now if you're observing patterns and learning occur, but I need a 1 over 1 minus x cubed series. So I should replace x with x cubed. So I want to write 1 over 1 minus x cubed series. 1 plus x cubed plus x6 plus x9 plus dot dot dot. That's x cubed to the power of n. What will that become? 3n. Everybody okay there? Are we there yet? I need a 2x squared over. So what should I multiply every term by? I hope you understand the logic. I'm going to multiply every term by 2x squared. What is the first term now we got? 2x squared. Next term. 2x5. Next term. 2x8. Next term. 2x11 plus dot 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 2x to the power of 3n. What? We're multiplying. We're multiplying every term by x squared. Plus 2, thank you. Here, times x squared. Ah no, we add powers. Are we done? Keep in mind, this is just f of x. So write down that was just f of x. Now, the question says find g of x. So what should I do with this guy? Integrate. Thank you. Last step, Ms. Marzuk and I were discussing the 109 homework, and she correctly said my left-hand side. I said, oh my God, that's so important. So my left-hand side is g of x, which is nothing but the integral of f of x. Look down. What's the integral of the first term? 2x cubed over 3. What's the integral of the second term? 6 over 6. What's the integral of the third term? Over 9. Fourth term? Over 11. Careful. What's the integral of the last term? 2x to the power of 3n plus 3 over 3n plus 3. Very good. Power rule. Okay. I'm forgetting one thing. If we've taken integral, so we should write plus c. Now, why did they give us this information? G of 0 is 5. If I plug in 0, will all of these collapse? So what is C then? 5. Thank you. So final answer is actually that guy. So write down plus 5. I hope you understand why. If you're writing good notes, Miss Wynn, next to that write down parentheses G of 0 is 5. So you know where that 5 is coming from. Okay, last round of the day, we will not do it. We will only talk about it. So I'm just showing you. So copy. This is on your homework. This problem is on your homework. I will not do it for you, but we will talk about it and say, oh, okay. But it was there on your weekend homework. Problems like this were on your weekend homework. Of course, I was guiding you then. But today you're on your own. Because I did the lesson. So it says, find the limit of that expression. Which series do we know? Everybody, Mr. Ordas, look at the board please. Which series do we know? Can we write the cos 2x series? And then, what is the question asking you to do? No. Cos 2x is that guy. What should we do next? Louder? What? Oh, okay. So she says replace x with 2x. Okay, then I have the cos 2x. What do I do next? The question is telling you what to do. What should I do next? Subtract the 1. What should I do last step? Divide every term by x squared. Is that clear? Divide every term by x squared. And the very last step, take the limit. Is that easy? So again, start with that. So observe the evolution of the problem. So look at your notes, how we evolve. When we started with this, when you change it, we change it, and then we follow instructions. Make a note to yourself, please. Just make a note. That just means divide every term by x squared. Divide every term by x squared. And then take the limit. Is that clear? It's absurdly easy. The homework has been sent, by the way. Oh, thank you. We're done. Thank you. We're done. I need a lid to this pen. Yeah. No. Sorry?
Yeah.
What?
Sorry.
Yeah.
So one.
No, I got it. So I have 1 over 1 minus x. I need 1 over 1 minus x cubed here. I replace every x with x cubed in the right hand side. It's a composite function. I replace every x term with x cubed. So we have 1 plus x squared. So that becomes 1 plus x cubed squared. Yeah, so then we get every x to 2. Frag 1. The 1 will cancel. And then divide every term by x squared and then take the limit.
Hey. My way.
Dude, what?
These are parallel this way.
I come back. Ah.
Make sure you do 2 things. You're finishing the homework and checking the solution. With both.
You arguing with me?
If 2 and 2 look the same, if they don't look the same, they add up to 1. Let me show you how.
Wait like 3 seconds.
Assume there's a then which other animals you want to create? Anteater, and then emu.
Because we divide x squared by b.
So what's this?
Yeah, it's
I'm
minus
gonna
1 of the entire thing.
look at monkey and panda. So here's how easy it is. Ask yourself if they open out. If they open out, is that open out also?
That's right, man.
Just set them equal and solve for the x.
That's funny.
Alright? So as soon as they say the 70 degrees,
Whoops.
That's a very
so
because it's minus 1
if
of
they
the
look
whole
alike, they're equal. So they're equal.
Josh,
If
you
they
gotta
don't
hear
look
that.
alike, then they add up to 180.
We're
So
plugging
that's give you an
into
example they don't.
to the series, and then you're
Look at
subtracting
monkey
1 from the
and
entire
anteater.
series. So it's
Monkey opens out. Anteater opens in.
It's just minus
So they
6
add up to
of the
180.
bracket and then minus 2.
That's it. That's how easy the lesson is. So assume they may say this is 2x and that is say 60
Seriously
degrees.
crazy.
So your equation is 2x
How long did
plus
it take
60.
you? Oh, I drew this a long time ago. How long did it take you?
Yeah, that's right.
I mean,
Let me show you another example.
in a day?
Say that's
See, I don't understand people like her because
I was rushing. No, you're like, it was nothing. I was starting
are these equal?
Oh my god, you're crazy.
Why can't you? Are they equal or are they
I don't
opposite?
get it. I don't get it. I don't get it. Oh my god. This is a force.
Yeah, because if you say opens out, opens in.
No, I don't get that.
No. This is unique.
Oh, so you mean this? You need to subtract 1? So, don't you, oh shit.
Again,
Don't you have a formula for the cos?
Acute,
Yeah.
acute. These are equal.
Yeah. And then after you get that,
So the trick is
subtract
to
1
put them on
the
a
whole
cube.
thing.
And they're
That's
equal.
what I've been saying.
Oh,
And then
so
you got solve
bracket
equation.
minus 1.
If they're- one is against the other obtuse, obviously this will add up to 180. That's
But
supplementary.
you don't want to trust
Subtract 1 from the
So,
whole
okay,
thing.
so these two, you write x30 plus 100.
Then after you do that, you divide each term
That's
by
all.
x squared. That's even the minus 1.
Equals 100.